I'm Anil Kumar. Welcome to my series on exponential and logarithmic functions. Now here are selected 4 questions on this topic which I find very interesting and useful. I've seen these questions many times in the test papers. Question number 1 is to solve logarithmic equation log to the base 9 of x plus 2 times log to the base x of 9 equals to 3. Here you will notice that the bases are different, so we need to use change of base formula. The next one here is to find inverse of the function 3 e to the power of 2x. You should also write domain and range. Then we have to sketch a function which is minus 2 log to the base 2 x minus 1 plus 3 discrete transformations. The last question here is solve 3 to the power of 5x times 9 to the power of x squared equals to 27. So that will be kind of an exponential equation where you have to use quadratic strategies. Now, you can always pause the video, answer these questions, and then look into my suggestions. I'll provide you with their solutions and take a small break in between to share with you some wildlife in the city of Toronto. Let's begin with the solution of the very first question, which is very interesting question. Solve log to the base 9 x plus 2 log to the base x of 9. Now to solve this equation, we should write them with the same base. I've specifically taken this example to make you understand that how we could actually work with change of base formula. Let us say we have log to the base a of x, and if we want to change the base to b, we could write this as log to the base b of x over log to the base b of a, correct? That is your change of the base formula. Now think like this. If I change the base to x itself, in that case what happens? Log to the base a of x. Now if I change the base to x, that means I write log to the base x of x over log to the base x of a. Now log to the base of x is basically 1. So I get 1 over log to the base x of a. Do you notice what has happened? I have written logarithmic function with base a now as base x 1 over that. Do you see that? So we are going to use this particular property of logarithms to solve this equation, and that is a very, very useful property. Clear? So let's solve now. So we could rewrite this equation as log to the base 9 of x plus 2 log, let me just first copy the question as such, right? And then I will use what I taught you here. So what we will do now, we'll change this second part as 1 over log to the base 9 of x. So we'll write this as log to the base 9 of x plus 2 over log to the base 9 of x. Does it make sense to you? So we wrote this as a reciprocal, changing or flipping the base and the argument. x9, 9x. Now we have the same base. Now it's easier to solve, correct? Let's multiply everything with log to the base 9 of x. What do we get? So we get log to the base 9 of x whole square plus 2 equals to 3 times log to the base 9 of x. Now that becomes a quadratic equation in logarithms. Let's bring them together. So we could write this as log to the base 9 of x whole square minus 3 times log to the base 9 of x plus 2 equals to 0. I can factor this product of 2 sum of minus 3. Right? So I could write this as log to the base 9 of x minus 3 times log of base 9 of x plus, minus 2 and minus 1, right? So because we need product of 2, which is minus 2 minus 1, and when you add them you get minus 3. Clear? Right. So that gives you two solutions, correct? Let me use this space for my solutions. So now we can say that log to the base 9 of x is equal to 2, or the other solution is log to the base 9 of x equals to 1. Perfect. Now these two gives two solutions to us. Let's write down the solutions here. When I say log to the base 9 of x equals to 2, it basically means x is equal to 9 to the power of 2, which is 81. So that is one solution. Clear? That is one solution. The other solution is writing log to the base 9 of x equals to 1 means x equals to 9 to the power of 1, which is 9. So these are the two solutions of our equation. So we get x equals to 81 and x equal to 9. Is that clear to you? So that is how we are going to solve this particular question. We'll find inverse of the function f of x equals to 3 times e to the power of 2x in this particular video. Now let us try to understand the function itself first. So we are given f of x equals to 3 times e to the power of 2x. What is the domain of this function? Let's write down. Now domain has no restriction. X belongs to real numbers is the domain. However, the range has restrictions, right? So the range is y belongs to real numbers, but y is greater than 0. Okay? When you actually sketch this function, you get what? In short, you get a function which is always increasing, kind of like this, right? So, okay, something like this. Is it okay? Now, we'll now find the inverse of this particular function. Inverse of the function, as you know, will be reflection on the line y equals to x. So if I have a line like this, it is going to be reflected on this line, and we expect something like this as the inverse of the function. Okay. Now let's talk about inverse now. As far as the domain of this inverse function is concerned, it will become like flip, right? So domain and range, they will flip. So the domain will be x belongs to real numbers where x is greater than 0, and the range will be y belongs to real numbers, correct? So whenever you're talking about function and their inverse, domain and range swap. So that is the first part. We should actually talk about domain and range for a function, definitely, when we are talking about inverse of a function. Now let's look into the process of finding the inverse. We could write this as 3 e to the power of 2x. To find inverse, what should we do? We need to swap, right? So to find inverse, first step is to swap x and y, correct? So x becomes y, y becomes x. So we write like this, x equals to 3 e to the power of 2y. Now we need to isolate y, right? Since we are working with e, we can take natural log both sides. So we get ln x equals to ln 3 e to the power of 2y, correct? So ln x equals 2. We can apply the product rule. So it will be written as ln 3 plus ln e to the power of 2y. Clear? ln 3 is basically a constant. Let's take it to the left side. So we get ln x minus ln 3. Here, ln e to the power of 2y is basically 2y times ln e. That is the power rule, correct? Now we know ln e, they are reciprocal. Here, since we are talking about take away, we could write this as ln x over 3, right? Equals to 2y. Since we know that ln e is 1. Correct? So it is kind of multiplied by 1. So from here we can isolate y as half of ln x over 3. Well, half of it means half of x over 3 to the power of half. That becomes y. So we can clearly write the inverse of this function as what? As ln x over 3 to the power of half. Is that clear? Whose domain and range is given here, right? And that is how the graph is going to look like. Perfect. So that is how we are going to find the inverse of our function. I hope the steps are absolutely clear. We'll sketch the graph of p of x, which is equal to minus 2 times log to the base 2 of x minus 1 plus 3. Now at this stage, I'm going to take my time to summarize all the concepts and go a bit slow, right? So let us first list all the transformations which we should be considering to sketch the graph of the given function, right? So each and everything here is related to transformations, right? So let's see how they are related. That negative is what? It is reflection on vertical reflection on x-axis, correct? This is first part. How about this 2? 2 is vertical stretch, so it is vertical stretch by a factor of 2. Now negative and then 1. This 1 means what? Horizontal translation. By how much? Just 1 unit. Which direction? Horizontal translation. 1 unit. Right. Correct. And 3 is vertical translation. Three units up. So combining all this, we get our transformed function. Now let us also look into the key points, right? So let's make our key points now. So whenever we are saying key points, it is with respect to the base function, which is log to the base 2 of x, correct? Okay. So let me make a table here so that we can clearly list our points. Let me make a horizontal kind of a table this time, since we have less space. Okay. So let's say we'll write down log to the base 2 of x, and then we'll write this function, which is minus 2 log to the base 2 of x minus 1 plus 3. Okay. So if we have a point in general which is xy, how is that going to get transformed? As far as the x value is concerned, we are only adding 1 to it, so it becomes x plus 1, correct? As far as the y value is concerned, we are multiplying by minus 2 and then adding 3. So we get minus 2 times the y value plus 3. So that is the basic transformation. Do you see the transformation formula here? That is how we are going to transform. So now let's look into the features. Okay, now one of the key features is the end behavior. So when I say x is approaching for logarithmic function 0 from the positive side, y basically approaches negative infinity. Now, as far as the x value is concerned, we have to add 1. Do you see that addition of 1, how it plays a role? So now we are saying when x approaches 1 from positive side, y approaches what? Negative of this value, right? So negative 2 times. That means positive infinity, right? So this time positive infinity. Do you see that major change? It's a huge change now, right? So let me just sketch this for you, and then we'll try to understand what is really happening, correct? So earlier we had a logarithmic function which was shown like this. So this is your log to the base 2 of x, perfect, the original function, on which we had been considering 3 points, right? Let these be the 3 points. And that was our end behavior. Is that clear to you? 5 key points. Now we are focusing on this point. See what is happening. When I say minus, this point actually shoots up. That is minus, right? So that minus makes it shooting it up, but then you are moving it by 1 unit to the right. That means the vertical asymptote has shifted from the y-axis to a position which is 1 unit to the right, which is practically here. Do you see that? So it moves here. So this is the value which is now equal to x equals to 1. So your graph is on the right side of this red line, and that is your vertical asymptote. Does it make sense to you? So this 1 actually shifts all these points by 1 unit to this side. Does it make sense to you? Okay. Now, so combination of these two, as far as the value infinity goes, means that you are now approaching here. Does it make sense to you? That is the first criteria. Now let's look into the points as such. So this point here was at half, the value was minus 1. Now to half, I am going to add 1 plus 1. That means 3 by 2, right? 3 by 2 is 1 plus half. The y value gets multiplied by minus 2, so that this becomes plus 2 plus 3 makes it 5. Does it make sense to you? So this particular point moves from here to, let me break the scale here since, they are going to be bigger numbers. So 1.5, that is, right? This was 2 for us. So somewhere here, it has shot up to a very high value, right? So let's say this point here is now 1.5 or 3 over 2, 5. Does it make sense to you, right? So that's your point number 2. Perfect. Now, let's look into the third point here, which is, so we have considered these are the relations, right? Now we'll see the next point here. The next point for us is this point, right? Now we are focusing on this, which is add 1, the value is 0. So if I multiply, 1, we have to add 1. So let's make it 2. And if I multiply anything to 0, it remains 0. However, we are translating 3 units up. So it changes to 3 units up. Does it make sense to you? So this particular point now moves from 1, 0 to 2, 3, right? So now it is at 2, earlier this point. So somewhere here, right? So 2, 3. So here we have a point which is 2, 3. Perfect. That's your next point. Now, the third point, which is a key value for us, is At 2, the value was 1 in the original function. So 2, I'm going to add 1 to it, it becomes 3. To 1, I'll multiply by negative 2, it becomes negative 2, plus 3 will give me positive 1, correct? So the third point moves to a position which is 3 units away, but 1 up, right? So 1 up. So you see how we are getting this graph, correct? So this graph here is kind of like this. Does it make sense? So that is the graph of our function p of x. Does it make sense to you? So you can see that when x is approaching infinity, y was earlier approaching positive infinity, but now when x is approaching infinity, y approaches negative infinity. So that becomes the end behavior. Perfect. So that is how we'll get the graph of our transformed function now. Does it make sense? So the major change here is that the domain has changed. The domain of this function now is what? Domain is x belongs to real numbers where x is greater than 1. Well, range is all real numbers, right? Y belongs to real numbers. That's okay, but the domain has changed. Even the end behavior has changed. Instead of approaching negative infinity on the vertical asymptote, it approaches positive infinity. But when x approaches infinity, it approaches negative infinity, right? So that is how we get our transformations done. So I hope that helps you to understand the complete concept of sketching logarithmic functions. Here we have a very interesting equation to solve. You could see this in some test papers at times. The question here is 3 to the power of 5x times 9 to the power of x squared equals 27. Solve means to find the value of x, right? So let me rewrite the equation. It is 3 to the power of 5x times 9 to the power of x squared is 27. So the idea is to write all of them with base 3. So I could write this as 3 to the power of 5x times 9 could be written as 3 squared to the power of x squared, and 27 is 3 cubed. Product, well, let's go one more step and then we'll combine the left side, right? So we have 3 to the power of 2x squared equals to 3 cubed. Now product means add the exponents. So we get 5x plus 2x squared, that is all to the power of 3, is equals to 3 cubed. Since the bases are same, we can equate the exponents and we get our equation, which is 5x plus 2x squared equals to 3. Clear? Now that is a quadratic equation. We can now solve this quadratic equation to find the answer. So let me rewrite this. It could be written as 2x squared plus 5x, taking 3 on this side, equals to 0. We are looking for a product of 6, sum of 5, positive 5. So plus 6 minus 1 can work for us. We get 2x squared plus 6x minus x minus 3 equals to 0. 2x is common in the first two terms, right? Minus is common here. We get x plus 3 as a common factor now. So taking that as our common factor, we get 2x minus 1 as the other factor. Now they are 0. That means x equals to minus 3. And here we get 2x equals to 1 or x equals to half. So we have two solutions here. The solutions here are x is equals to minus 3 and x is equals to half, right? These are the two solutions. Now what I would like you to do is basically check your result. So whenever you do exponential equations, solve them, it's a good idea to check. So if I substitute x as minus 3, what do I get? Let's do it, right? So if I substitute minus 3, let's do it. In that case, I get 3 to the power of 5 minus 3 means minus 15, and 9x squared means 9 to the power of minus 3 means 9, right? Correct. Now, as we learned, this is minus 15. This is 3 squares. So that means 3 to the power of 18. And when you add them, what do you get? You get 3 to the power of 3, which is indeed 27. So that is correct. Let us also check the other result, which is half. So if I write, we get 3 to the power of 5 times half, and here we have 9 square. So we have 3 to the power of 2 times half square. Is that clear? Right? So kind of I jumped to this step, right? So what is that equals to? That means 3 to the power of 5 over 2 plus, here we get what? One of the 2's cancels, right? So we have 2 over 4. 1 over 2 is what we get, right? So this is 1 over 2. So that is 3 to the power of 5 plus 1, 6 over 2, which is 3 cubed. So that is also 27. So both work, correct? And therefore, our answer is correct. It is both x equals to minus 3 and x equals to half. So I hope that helps to understand how to solve exponential equations. Feel free to write your comment, share your views, and if you like, subscribe to my videos. That will be great. Thanks for watching and all the best.